And in this part, what I'm going to give is some topics like this. First, the fundamentals of Matlab programming. For instance, the data types and other statement types, something like this. Then, I shall talk something about mathematical calculations. For instance, algebraic calculations, logic calculations, something like this. And in the third part, I will have something about the flow control Matlab programming language, such as loops, switches, and other conditional structures, something like this. And then I will say something about writing and debugging Matlab functions, how to write functions in Matlab. And also I will show you some of the visualization problems, two-dimensional graphics and three-dimensional graphics. And these are the essential parts of Chapter 2. As I have told, Matlab has certain advantages like this, and they are easy to program, and it is quite high-level structure and good for scientific calculation and all other engineering disciplines. And also it has very good graphical facilities. You can draw graphs or surfaces easily using simple commands. Also there are a huge amount of toolboxes and block sets. I will explain the differences between them later on. And these toolboxes are designed by the experts of the disciplines. So these toolboxes are with high reputation, so you can use them reliably. And also it has powerful simulation facilities, because you can combine the system and the different domains and unify them in the same framework to perform simulation. I think this is a unique property of Matlab. So let's see some fundamentals of Matlab. First, I will explain variables and how to compose variable names, and then the constants, how to use them in Matlab. Then I shall say something about the data types, and then the structure of Matlab commands, and then how to express matrices, and how can we create a column expression for vectors, and how to extract matrices information, something like this. In Matlab, the essential part of Matlab is variables, just like C. You can use a variable name, and there are some restrictions on the name of variables. The first character in the variable name must be a letter, English letter. It can be followed by any other underscores or digits, but the first character should be a letter. It can be in capital letters, small letters. So the first one should be a letter, and the rest of them could be digits or underscores. It's slightly different from C programming language. And Matlab is case sensitive. And there are some examples. These are valid names, and these are invalid names. So you can use this discipline to create a variable name. Also in Matlab, they have predefined many constants. For instance, I and j for the square root of -1, and also pi. And EPS, which is the error tolerant number, which is quite small. It should be machine dependent, but it is an error tolerant constant. I will explain it later on when we use them. And also there are two interesting constants. The first is INF for infinity. If you use 0 as the denominator in them, then you can get infinity. For sometimes you get minus infinity. And also you have NaN, which means not a number. If you multiply infinity and 0 together, we may get NaN. And I shall explain them later to you when we meet them. Now, the data types of Matlab. For mathematical computation, normally we use two kinds of data types. One is the numerical one for double precision data type. And the other one is for analytical solutions. So we use symbolic data type. So they are quite different. And also, as a programming language, it has also other data types. I will explain them later to you. The double precision data type, which is used in numerical computation, is a 64-bit data type, 8 bytes. So it is under the IEEE standard. So we have 11 bits for exponentials, 53 bits for numerical numbers, and 1 sign bit. And if a number is not given in double precision data type, we can use double command to convert it to double precision data type. And the data range is something like this. You do not have to memorize all this. Apart from the double precision data type, we can also have something like this. And you can immediately recognize what they are. For instance, this is unsigned integer of 16 bits. And they are sometimes useful. For instance, the UINT8 is quite useful in image processing. It will require only 1 byte. So it is enough for express image pattern. Another useful data type is the symbolic data type. I have used the command SYMX since X to declare that X is a symbolic variable. So once you want to derive formulas directly, then you have to specify the symbolic variables, and you can declare several symbolic variables together separated by space. You can declare several variables, and you can also declare the properties of the variable. For instance, you can use real or non-zero or positive, something like this, to declare symbolic variables. And also you can display the symbolic variables with the VPA for variable precision algorithm. I will demonstrate this one later on to you. I'll use this